All right, so let's have a look at a complex number excellence question. This is to do with finding roots of a complex number. And the question says, so if p of z, I'll use z with a little line in the middle just so it doesn't get confused with 2. P of z equals z cubed minus I z squared plus 6z plus b, where I and b are real numbers, not imaginary. And it has, so when you solve equate it to 0, you'll end up with the 2 imaginary roots and 1 real root. If p of 1 minus I is equal to 0. So pretty much when you have a cubic, you end up with like a 3 different brackets, like for example, it's x cubed, something x plus I into x plus b, x something. If you have a long x, x cubed expression, something like ix cubed plus bx squared plus cx plus d equals 0, then pretty much your roots are x minus a times x minus b times x minus c. And so we use the same method to solve this question, and therefore okay, so I'm going to use the cubic format, and that is z minus 1 minus I times z minus 1 plus I. So if 1 minus I is a root, then the conjugate would be a root as well, which is 1 plus I. And then I'm going to say z minus alpha is another root, and we'll try and see if we can find alpha and then see if we can substitute and find A and B. Okay, so I'm going to write this again on the next page, and then we'll see if we can solve it. Okay, cool. Give me a sec. Okay, so what we have to do is we have to remove the brackets on the inside and match the real and the imaginary component so we can expand the bracket. So we are going to do this first. Since there's okay, so what will happen here is next is z minus 1 minus I into z minus 1 plus I z minus alpha. So if you multiply this with that and this with that, the terms will be the same and they will cancel, so it's like a difference of squares. So pretty much what you end up with is z minus 1 whole thing square minus I square, which would be z minus 1 square minus I square into z minus alpha. So z minus 1 square, you can use the perfect square, or you can write it double and multiply it. So you end up with z square minus 2z plus 1 plus 1. I squared is minus 1, minus 1 is plus 1, into z minus alpha equals 0. So this simplifies to z square minus 2z plus 2 into z minus alpha equals 0. Okay, cool. So once we have this, then we expand. So I'm going to go to the next page, write this down, and then we start expanding. Okay, so take the first term and we multiply it with first term, you end up with z cubed. And then take the first term, multiply with the second term, you end up with minus alpha z squared. Then take the second term, multiply with the first term, you end up with minus 2z squared. Multiply with the second term, you end up with plus 2 alpha z. Sorry. Take the third term, multiply the first term, you get plus 2z and minus 2 alpha equals 0. So what we do next is we combine the like terms. So there's a squared and a squared, and there's a z and a z, and so we end up with z cubed. So minus alpha minus 2 would be minus 2 plus alpha z squared, because if you open the bracket you end up with minus minus sorry, plus, so 2 alpha into would be plus 2 into alpha plus 1 z. So if you open the bracket you end up with 2 alpha into z minus alpha z equals 0. So if we go back to the original function, the original function said it is p of z equals z cubed minus I z squared plus 6z plus b. So we know that one of the coefficients, so what we pretty much are trying to do is we're trying to see if we can equate the coefficients and find them pretty much. So the coefficient of z is 6, and therefore that's something we can solve. We can use this particular scenario here, equate them and solve for alpha. So 2 into alpha plus 1 is equal to 6. So if you divide 6 by 2 and then 3, so alpha plus 1 equals 3. Therefore alpha is equal to 2. Hey, once we get alpha we can solve the rest of them. So I would pretty much be, so alpha, once alpha is 2, which means if alpha is, so what that means is I would be now equal to 2 plus alpha, which is equal to 2 plus 2, which is equal to 4. For A, we want to find B, so B would be equal to minus alpha, hang on one second. I think I made a mistake here. This is minus 2 alpha, I'll change that to minus 2 alpha, and that is equal to B. So B is equal to minus 2 alpha, which will give it minus 2 times alpha is 2, which makes it minus 4. Therefore, the question had said find IB, and I is equal to 4 and B is equal to negative 4, and there you go. So you can use pretty much solving a cube and equating the coefficients to solve. Alright, cool, thank you.